You are determined to sweat it all out today. You put your elegant sports shoes on and head to the gym. You decided to do some cardio workout, so you plan to run on the treadmill. While listening to music, you're suddenly wondering, how can I just stay in the same position even though I am running forward? That's a good question to ask yourself. To rationalize more what you are thinking, stay tuned and continue watching this video. Hi, Assalamualaikum and a very good day. My name is Haikal and welcome back to Siri Pesyarah Kimia Awak. Today we'll be learning about new chapter which is dynamic equilibrium. System in equilibrium are balanced. As what being shown to you before, if you are running on the treadmill, you are basically in constant motion. The rate of you running on the treadmill is basically the same as the rate of the treadmill moving you backwards. So I can say that you are in equilibrium with the treadmill. This concept is applicable to chemical reaction. Before this, you always deal with a chemical reactions that goes with A plus B going to C plus D. This is known as non-reversible reaction or forward reaction, where reactant A will interact with reactant B in order to form product C and D. However, the chemical reactions in reality can happen in a reversible manner, where it occurs almost every time and almost at every cases. So just now, I've shown you the forward reaction where A plus B equal to C and D. But now, in a new reaction, you can say that A plus B can go to C plus D, and at the same time, C plus D can go back to A plus B. And this one is one of the characteristics of dynamic equilibrium. You will learn more about this later. So what are the characteristics of a system in equilibrium? The first feature is the concentration of the reactant and product must be constant over time. Second, the rate of the forward reaction must be the same as the reverse reaction. And third, the reaction quotient must be equal to the equilibrium constant. But you don't have to worry about the third part because we will be dealing about this in the next video. Okay, there are two types of equilibrium. We have physical equilibrium and chemical equilibrium. So let's look at the first one first. By meaning of physical equilibrium, it basically means that there is no change in chemical composition, but it's just changing in the state of matter. The chemical is still the same. For example, water is still water, but it's just changing in the state of matter from liquid to gas. Let's consider the water in a container. So as what you can see here, at first, there's a lot of liquid water. But as time goes by, the liquid water will evaporate and form a water vapor. So as time goes by, the rate of the liquid water to form water vapor and the rate of the water vapor to goes back into liquid water will be similar. And hence, we can say that the reaction has reached equilibrium.
You moved on to someone new. Whole life is beautiful.
For chemical equilibrium, we can imagine as 2 mole of dinitrogen tetraoxide decomposes to form 2 mole of nitrogen dioxide. At first, the chemical, the surrounding will be colorless. But as time goes by, there's a changes in colors where there is, from colorless, it will go to pale brown and it slowly darken to dark brown. So at a certain point, you will see that the color changes from colorless, pale brown and dark brown for a certain time. So at the time when there's no color changes, we can say that it has reached equilibrium. But when it reaches equilibrium, we doesn't see that the reaction has stopped. It just stays, the reaction is still going on, but it just reached equilibrium. Now, let us consider the graph of the rate of reactions against time for a reversible reaction of dinitrogen tetraoxide converting to 2 mole of nitrogen dioxide. As what you can see here, from 0 to A, we can say that at the forward reaction will be much higher than the reverse reaction. And now, we let the reaction to proceed until it goes to time B. At time B, we can say that the rate of the forward direction started to get reduced. Meanwhile, the rate of the reverse direction started to get higher, and this is indicated by a yellow arrow here. And now, at time t, which is indicated by the green dashed lines here, we can say that the rate of the forward direction is the same as the rate of the reverse direction. Hence, we can say that the equilibrium is established at time t1. But what will happen after time t1? As what you were already wondering, after time t1, the reactions basically does not stop. Instead, the rate of the forward reaction will always be the same as the rate of the reverse reaction, which means that it is still in the state of equilibrium. The state of equilibrium is maintained and does not shifted as long as there is no external pressure or external factors that will apply to the closed system. Next, we will consider the curve of the concentration against time for a reversible reaction of the same reactions that we have seen. So as what you have understood, at time t, the equilibrium is achieved. However, we know that the concentration of the reactant will not be the same as the product. If this one is meant to be 100 molar, this one will be 60 molar, and it is consistent at equilibrium. And we can say that the concentration is consistent after time t. What is equal is the rate of the reaction between a forward reaction and reversible reaction. However, the concentration does not meant to be equal. It's just being constant in equilibrium and constant at equilibrium. I hope you find this video helpful. To summarize what we have learned today, first, we have learned about forward reaction and reversible reaction. Second, we have learned about the types of equilibrium, which is physical equilibrium and chemical equilibrium. And the third one, we have learned about the characteristic of a system in equilibrium, where you know that the concentration of the reactant and product must be constant over time. But it does not mean that the concentration of the reactant equal to the concentration of the product. And third, at equilibrium, the reaction does not stop. It just means that the reaction happens to go by at the same rate, where the forward reaction is the same as the backward reaction. Okay, that's all from me. Don't forget to share, like and subscribe. Keep smiling, keep working hard, and stay safe. Assalamualaikum and goodbye.